Hello everyone, thanks for tuning in. Today I'm going to talk about Prometheus and its future, about all the exciting futures that we have in store for you. I'm Gautam, I'm a Prometheus and Cortex maintainer working at Grafana Labs. I've been involved in the Prometheus ecosystem for about 4 years now, and I was at one point the Prometheus storage maintainer. Having said that, over the last year or so, I've been mostly focused on Cortex, which is another Prometheus ecosystem project. But I still have been tuned into the Prometheus ecosystem and the Prometheus project, and I'm going to share all the latest things that have been happening. I've given this talk at the last GrafanaCon more than a year ago, and about 6-ish months later, Beyond gave a similar talk at DevOpsCon. But if you watch both the talks, you'll realize that there's very little in common between the two talks, and Beyond still had a lot of things to cover over of all the developments that happened in the 6 months after I gave my talk. And it's the same state now. I have an entire talk of all the new and latest things that happened and are going to happen in Prometheus. So watch those talks if you want to see what's been happening over the past 2 years in Prometheus. But let's dive in. So in this talk, I'm going to cover the history, a brief history of Prometheus to give you a little context, and all the latest, or basically a few of the highlights of what happened in the last 1 year, and then what we have in store for you. All right, history. So a bunch of ex-Googlers joined SoundCloud, and one of the first things they realized in this startup was, wait, what happened to all the cool monitoring tools that I was used to inside Google? There were a ton of different monitoring tools in the ecosystem at that point, but none of them were good enough. So two ex-Googlers, Matt and Julius, started working on Prometheus, and as you can see, the first commit was in November 2012. So they initially started working on it in their free time, but then SoundCloud realized how important the new monitoring tool was, how cool it was, and it let them work on it during work hours. And it also started using Prometheus in production. So there were more people who joined the work on Prometheus. There was a lot of adoption inside SoundCloud. They started using Prometheus to monitor thousands and thousands of servers. And about 2 years later, SoundCloud releases Prometheus as an open source project. It was always open source, but they released a blog post. They talked about it. They started making noise, talking about it at conferences. And that was like the birth of Prometheus. And about a year later, it joins the CNCF as the second project after Kubernetes. And a few months later, Prometheus 1.0 was released. If you can see, this was nearly 3.5 years after the project first started. And at this point, already a few hundred companies were using Prometheus in production, maybe a few thousand. And it was pretty stable and pretty performant at this point. And then about a year and a half later, we released Prometheus 2.0. So this was a huge release in terms of the changes and features. But one of the main things was we've seen a lot of companies use Prometheus in production at small scale, at large scale. We've talked to all those people. We've noted all the pain points they were facing with Prometheus and kind of worked towards fixing all of them. We made a lot of breaking changes. We kind of rewrote the storage engine from scratch to be 3 to 5x more performant on all scales like CPU, memory, storage. And we made all the breaking changes we wanted to make. This was a very big release and very well thought out release. And today we are at 2.1a, 2.18, and it's been what, 2.5 years since we released 2.0. We're not going to release a 3.0 anytime soon, because again, there's nothing we want to break. We've improved Prometheus a lot since 2.0, something that I'll cover. But yeah, so this was a huge release, a well thought out release in the Prometheus lifecycle. Anyways, moving on. A year later, we graduated within CNCF. Basically, a CNCF graduated project just signals that it's ready for production in small companies and in enterprises. So far, it's been great. But now the question is, we've released 2.0 and then we've graduated. Is the project done? Actually, you will see that it's not really. So there has been some, let me use the pointer more. Anyways, ignore this. There's been some development since the start, and then when there was the public announcement, a lot of traffic was driven to the Prometheus project. And then soon after, like, you can see that the growth in the activity in the Prometheus ecosystem has been like linear or like sometimes even exponential. And today the project is more active than it has ever been. And this also doesn't cover the entire ecosystem. So this is just the Prometheus org on GitHub. We also have the Prometheus community org, which I will be talking about. So today we are actually far more active than what this graph shows. But this also shows you that we are not going anywhere and we are constantly innovating. So let me share you a few highlights of what has been introduced into Prometheus over the last 1 year. So first thing, we've added 4 maintainers. We're about 20 maintainers right now working on different parts of Prometheus. And the good thing about these 4 maintainers are they work for completely different companies, 4 different companies, and a lot of them are paid to do Prometheus, which is amazing. Callum here also works for Grafana Labs. He's been working on the remote write part of Prometheus. Bartek is a Thanos maintainer, and he has been helping with TSDB and like overall a lot of things that relate to Prometheus. I should also say Julian is our newest Prometheus team member, and his contributions have been phenomenal before, but like even after joining team, he just accelerated his commitment, and we are quite glad to have Julian on board. Cool. Now that we have more people working on Prometheus, let's see what we have been churning out. So this is the Prometheus UI, the graph UI, or like the exploratory UI. Like you can see that a lot, like if you have been following the project over years, there has not been a lot of changes to this UI. We kind of upgraded Bootstrap and it became a little more modern looking, but the functionality was basically same, which is a good thing. Like it works and it was feature complete to a large extent. And anything that the Prometheus UI doesn't do, we actually decided that Grafana would be a better place, or a different dashboarding solution would be a better place. Having said that, because it was in JavaScript and it's a it's a UI, it has not seen a lot of contributions from the community, and there were some changes we wanted to make. But Julius last summer started working on a completely new React UI, which we've added recently. So if you look at it, it looks almost the same as the normal Prometheus UI. So basically, if you are using Prometheus, you just click on the experimental React UI, you get taken to the screen. You can also click on the classic UI button to be taken back. So since we've added the React UI, we've seen a ton of contributions from the community, and there's a lot more issues. It's not fully feature complete or like feature comparable to the classic UI. We still need to add some more pages, some more features. So if you're into React, if you're into frontend, please contribute. And this was added in 2.14, and every single release since then, we've constantly added more features, made it faster, more consistent, and we have a lot more things planned. All right, that's about the new UI. And in 2.15, we added a new metadata API. So this is, for me, one of the biggest lifesavers. So a lot of times someone else creates a dashboard with a metric foo. You kind of want to understand what this new metric name is. For example, if it's container, FS read, seconds total, like what does this metric mean? Is it a counter? Is it a gauge? Is it a histogram? Like, so this information is not present. Like it's kind of hard to figure out what a particular graph means, what a particular query means. But recently in 2.15, we exposed a new API in Prometheus where UIs can query Prometheus for the help and type information that Prometheus stores. So if you're using the Grafana Explore UI, you can just type the name of the metric and it will show you if it's help and type information. This is going to be super useful while exploring. And now that we have the new React UI, we are working on adding the same feature to the Prometheus UI. So you don't need Grafana, but as of today, if you use Prometheus 2.15 or more and the latest Grafana, you will be able to use this. Great. So this next feature is something super critical, and it's been open since a long time. It's isolation. So this is isolation in the asset context of databases. For example, so I'm going to explain this with an example. Let's say Prometheus is scraping a target that is exposing 10,000 different metrics. So Prometheus scrapes the target, it adds these 10,000 metrics to its database. Now, if you issue a query, you might see partial results. For example, let's say Prometheus scrape the target and it's like, okay, let me add the metrics one by one. Suppose it's added only 5,000 metrics and you issue a query, your query will only see the first 5,000 metrics because the rest of them are being added at that point. So this usually doesn't cause problems, but sometimes it might trigger some alerts in when using histograms or other complex types, because the value of one metric depends on the value of another metric. Like if you have several buckets, you kind of want to see all the buckets at once. This is extremely rare because even if you're ingesting 10,000 metrics in a scrape, it happens in milliseconds or like even nanoseconds. But there can be this race condition which can cause wonky issues in the rarest of cases. It's not a very easy fix. As you can see, Brian Brazil first opened a PR in 2017. And about a year later, I took over that PR and fixed it and rebased it and made sure it worked. And even in 2018, we couldn't get it merged. But recently, Beyond took over, took the state from 2 years ago. He put he made sure everything works. He tidied it up and he focused on getting it merged. And as of 2.17 Prometheus, you now have isolation. You will not see a partial scrape. You'll either see the entire scrape or none of the scrape, which is amazing. And this is one of the oldest issues open in Prometheus. This was even an issue for Prometheus 1.0, but it's finally closed. Great. So this is just a small snapshot of all the features and improvements we've made. Having said that, in every single release, we are focused on making Prometheus faster, use less memory, CPU, or space. So these are just a small snapshot of the different performance or performance optimizations that we've been doing into Prometheus. So every single release that you upgrade to, your Prometheus will be leaner and faster. So always keep upgrading your Prometheus. Just because there's no fancy feature, don't stop upgrading. You'll notice that your queries will be faster. Anyways, moving on. So this talk is about the future of Prometheus, right? So that's what I'm going to get into. The first thing, it has to do with tracing. So I love monitoring. I've been in this space for 4 years, but recently I've fallen in love with distributed tracing. You should watch my talk at PromCon about how Prometheus and Jaeger, a distributed tracing system inside CNCF, can work together to make sure that your services, you can observe and improve your services. So in that talk, I talked about exemplars. So what are exemplars? So for example, you instrumented your application with the RED method where you have requests, errors, and duration. So on the left-hand side, you have the requests and errors. So far, this application is doing 2 queries per second, and all of them are succeeding. And on the right-hand side, you have the histogram panel, which kind of shows you how the distribution of latencies is. So in this histogram panel, you can, if it's darker, it kind of means that most of the requests during this time range are taking between 10 and 25 milliseconds, while there are a few requests that are taking between 500 milliseconds and a second. So the darker it is, the more requests there are. So the whole point of exemplars is, if you have 10 different services in your request path, so you send somebody hits your service, and then you talk to a database, you talk to a scoring engine, you talk to a search engine. So it's like if you call 10 different services and then you return the data to the user. Now, if this request takes 10 seconds, you don't know which service added this latency. Are each of these different 10 services adding 1 second of latency each? Or is one service adding 5 seconds of latency? You kind of don't know just by looking at a simple graph. For that, you can use distributed tracing. So the whole point of distributed tracing is it will tell you exactly how long a request took and what function took how long. which is amazing when, especially when debugging slowness and other things. But figuring out which traces to look at is tricky. And that's where exemplars can come into picture. So each of these different blocks that you can see will be clickable in the future. And if you click on this particular block, you will see you'll be taken to a distributed trace that fell between 10 milliseconds and 25 milliseconds. And if you see a lot of red here, and if you click on that block, you'll be directly taken to a trace that took 50 seconds. So that is exemplars. So basically, when your application is using distributed tracing and Prometheus, it adds the tracing label to all the histogram buckets, and Prometheus stores this data. And in the future, Grafana can query the data saying, okay, for this bucket, please give me all the trace IDs, and Prometheus will be able to return the trace IDs. So the status of exemplars is currently we have a design doc and an internal proof of concept that we're working on, like the whole end-to-end application exposing trace IDs, Prometheus storing it, and then Grafana querying it. And once we have the proof of concept ready, we will make it public. We almost have consensus on the design doc. There are still some kinks, but hopefully in a few months, maybe a quarter, you will be able to see exemplars in Prometheus and the ecosystem. All right, next. So this is currently the most oldest open issue in Prometheus, backfilling and retroactive rule persistence. So a lot of companies are moving to Prometheus nowadays, like small companies, big companies, enterprises, everyone. And they already have an existing monitoring system that might have 3 to 5 years of data. And when they move to Prometheus, they want to migrate the data to Prometheus so that they don't need to maintain the old system, or they don't want to like lose all that data. And currently there's no easy way to do it in Prometheus. Similarly for recording rules. So when you open a dashboard, if you suddenly find that one of your dashboards or panels is taking like 5 to 10 seconds to execute a query, you can write a recording rule for it, which is like a pre-aggregation for that query, and replace the dashboard with the recording rule. Having said that, if you create the recording rule today, you'll have the pre-aggregated data from now onwards. We don't backfill that data, which means if you immediately change your dashboard, you will see a gap, and then you'll see the recent data present in the dashboard. So what people typically do is they add the recording rule, wait for a week so that there's enough data for the recording rule, and then replace the dashboard queries with the recording rule queries, which is non-ideal. And both of these play into the same thing, which is basically we want to store older data into Prometheus or backfill data. So there has been a lot of interest in it. We kind of made it possible code-wise and architecture-wise in Prometheus, but there's no real API that people can use, that people can send data to. So Bartek, one of the Thanos maintainers and Prometheus maintainer, he took this up. He floated a design doc, an issue, and started discussion around this. And we've kind of settled on the remote write API as the API you use to kind of backfill data into Prometheus. And I think it's a community built project now. And Bartek and Callum are mentoring it. So hopefully by the end of summer, we will have backfilling and retroactive rule persistence in Prometheus. Sorry, give me a second. Yep. Next I have TLS, to node exporter. So one of the things in Prometheus is we have no authentication or authorization in Prometheus or its exporters. And typically we ask people to use a reverse proxy in front of the exporters and Prometheus to secure them, which while it works and a lot of people have been using, it's non-ideal. Ideally, we want to protect the exporters. Sometimes your metrics might have sensitive data, to make sure only Prometheus or authorized applications or people are accessing those exported data. We haven't added it for a long time, but quite recently, actually, it was merged November 15th, like about 6 months ago. We've added the first version of TLS to Node Exporter, and Node Exporter 1.0 release, which will go out maybe this month. The RC.1 was cut today or yesterday, I forgot. But yeah, so Node Exporter 1.0 will have TLS support, so you can secure your exporter, at least Node Exporter for now, with TLS. And once we've seen people run it, we got enough feedback, we'll slowly add it to all the other exporters in the Prometheus ecosystem. So your exporters can be secure by default, which is pretty cool. A lot of people have been driving this work: Ben, Brian, Fish, everyone, and the community. Thanks for all of that work. And soon we'll have TLS secured exporters by default. All right, great. Yep. So next up, I want to talk about Prometheus community. So this is something that's very important to us. So we have the Prometheus server, we have Alert Manager, and we have a few exporters in the official Prometheus org that the Prometheus, like the Prometheus team members can maintain. Having said that, if you Google for Prometheus exporters, you'll see a list of thousands of those exporters. And we want to support the community with resources, with mentorship, with maintenance and all of that, but it just doesn't scale with just the Prometheus team. So to enable the community, we created the Prometheus community org with its own governance, where all the popular exporters, if they are interested in it, will be accepted. We'll go through the exporters, we'll make sure that the exporters are up to date, that any critical issues are fixed, that they follow best practices and all of that. And we are slowly adding exporters and ecosystem projects. So it's not just exporters. If you can see, this is like Monaco support for PromQL, like syntax highlighting, if I'm not wrong, and other things. So far, the Prometheus team is about 20 people, but we already have 33 people as part of the Prometheus community, and it's just growing every single day. Like every week or two, I get a notification saying, here's a new project that has been moved to Prometheus community. So yeah, if you are into, if you have an exporter that you want to contribute to Prometheus community, or if you want to help maintain the list of projects that we have as part of the ecosystem, please join Prometheus community. You can find more details at prometheus.io/community. Cool. Next. Yep. So this is again one of my favorite projects, OpenMetrics. So there's a lot of lock-in in the monitoring ecosystem, even though, so, okay, let me give you a concrete example. So if you want to move from a monitoring system X to Prometheus, it would involve you going through your entire code base and changing every single instrumentation point to the Prometheus library. So this is extremely prohibitive, and there are ways to get around it, but it's not ideal. So we created the OpenMetrics project along with the other monitoring projects and vendors in the ecosystem to create a standard format for transmitting metrics at scale. So essentially, the whole idea is there will be one format which all the monitoring systems will be supporting. So today, if you're using Prometheus and if you want to kind of move or experiment with a different monitoring system, in your applications, you can just change one line saying, okay, output Prometheus, please also output to monitoring system X, or like you just add one more line and you will be able to send all your metrics to a different monitoring system without a lot of effort. You just need to change one or two lines of config. And this is important, one, because this is building on top of the Prometheus exposition format, which is really, really good. And it also helps a lot of people move from other monitoring systems to Prometheus as well. Yep. So a small update on this. So like it needs a lot of work to write this to write the spec. Having said that, Richie and other people they're working on it, and they have committed to getting the spec out in the next 3 to 6 months. So fingers crossed for that. So this is something which is really, really cool, Prometheus histograms and their future. So today in Prometheus, if you want to use histograms, you have to pre-specify the buckets of the histograms. And this involves kind of guessing, okay, I want to use a histogram to monitor latency, and my application will typically have a latency between 5 milliseconds to 5 seconds. So you create a buckets according to your guess, and then you deploy your application, and suddenly you realize your application, actually the correct value or correct range for that is 5 seconds to 15 seconds. Now you have to go back and change the code. And we are working on improving histograms. Beyond has an amazing talk at PromCon, a lot of which went over my head, but it's really cool. What if you just declare a histogram and then start observing data, and you don't need to pre-declare your buckets, and Prometheus will take care of the rest? So sounds really cool, right? It requires a lot of changes, and Beyond has been experimenting with a lot of research papers and algorithms. And in a few months, he will, or like in less than a month or so, he will be releasing the initial version of his research results. Fingers crossed for that. It's super exciting. Yep. One more thing. So this presentation is incomplete if we don't cover the ecosystem projects in Prometheus itself. So to give you some context, Prometheus is an amazing system. It works really well, but you need to run Prometheus close to the applications itself. This means if you have different data centers, you need to run a Prometheus in every single data center. So for example, if this, let me use the pointer here. So assume this is the EU Prometheus and this is the US Prometheus, and they're monitoring the same applications running in an EU data center and US data center. So the EU Prometheus will give you the request total in the EU data center. The US Prometheus will give you request total from US. Now you can hook Grafana up to different Prometheus servers and visualize the data together, but you cannot combine the data together. For example, you will be able to say, hey Grafana, in this graph, show me the EU request total and US request total, but you cannot write a query that says, give me the combined request total from both EU and US. You can do that via federation. Basically, you can select certain metrics or pre-aggregate certain metrics and let a central Prometheus collect data from the different leaf Prometheuses, and Grafana can query the central Prometheus for this aggregated data. But this is tricky, like it requires a lot of configuration, and you need to kind of beforehand know what metrics that you want to aggregate on. If you want to do some ad hoc analysis, it's not trivial. So to solve this problem and a few other problems, there's a lot of ecosystem projects like Cortex and Thanos and M3DB and InfluxDB, to help you solve this problem of aggregation across different Prometheuses or long-term storage or distributed storage. So in these different things, either Prometheus writes all the data to a central store, or like in the case of Thanos can actually query the different leaf Prometheuses and combine the data. So I want to focus on like Thanos and Cortex, two ecosystem projects which are driving a lot of innovation in Prometheus itself, and there's a lot of innovation happening in those projects. So both of these are CNCF projects. Both of them are open source. But the really cool thing is there's a large overlap of maintainership between the three projects. Like both Thanos and Cortex have a huge chunk of Prometheus maintainers, and there's a lot of overlap between the Thanos and Cortex maintainers as well. So this is really great because one, we like both the projects depend on Prometheus libraries to do their work. Like we use the storage engine, we use the query engine, like we use a lot of code from Prometheus. And this means while we are working on improving Cortex and Thanos, we are also contributing features and fixes back upstream into Prometheus. And this is a small snapshot of what's happening. And yeah, this is something super exciting because different projects with different goals are working working really closely to improve each other. And I'm like, this is open source, as Bartek says. Yep. All right. So to kind of, sorry, give me a second. To kind of summarize, the Prometheus projects does have a roadmap page. I linked that in the slides. And if you look at the roadmap page, it says these few things. Server side metadata, metric metadata support, which we partially have, like the whole help and type information, that is the metadata that we are storing server side, but we are not persisting it to disk. Like if you restart Prometheus, you lose the data, but you get the data after a single scrape. So we still want to persist data there. So it's not fully done. Adopt OpenMetrics. Yep, we are working on OpenMetrics, and soon we will be adopting OpenMetrics and helping the community adopt it. Backfilling of time series, I talked about it. It's going to be a community bridge project. So hopefully by the end of summer, that will be done. TLS and authentication in HTTP serving endpoints. So yep. So The idea here, as I've covered, is once you have in Node Exporter, we will wait for feedback from the community, and once we've tuned all the features of the TLS config, we will add it to all the other ecosystem projects like other exporters, Prometheus itself, Wallet Manager itself. Supporting the ecosystem, that is part of the Prometheus community project, like the Prometheus community org. This will never be done. We will always continue to support and expand on the community and ecosystem. Yep. So as you can see, we've kind of like, in the next 6-ish months, we will be done with most of the roadmap. So hopefully, next time you see me, I will be talking about a brand new roadmap. All right. So that's all that I have to cover. Oh, sorry. Yep, there's one more thing. We have a monthly Prometheus community call, super interesting. All the Prometheus, like Prometheus updates, Prometheus community project updates, and any questions you can directly ask the Prometheus maintainers in this call. So it happens every Wednesday, like every first Wednesday of every month, either 9 a.m. UTC or 5 p.m. UTC. So you can join when it works for you. Yep. So yeah, please join the community call. Please ask questions, and if you have cool projects to share, please use the community call. All right. So for questions, we're now going to head to Slack. Please ask all your questions in Slack, and I will be there along with other maintainers to help answer them. Thank you.